All right, so today we're going to do subtracting rational expressions. Rational expressions is like division is to multiplication, subtraction is to addition. It's the same steps except one extra step in it. And I've kind of reconfigured the steps after our last video. I like these steps better. I mean, they're all the same. You can do it in whichever order you like. I've just been doing it the same way for so many years. So you can do these same steps for adding. The only thing that is new for subtracting is going to be this. That's the only new thing. Okay, everything else is what you do for adding except number 2. Okay, so before we get there though, let's do a flashback with subtraction with rational fractions. So say you have 7/8 minus 1/6. You remember the keep, change? So you keep your first fraction, you change subtraction to addition, and then you change the sign of the one behind it. Keep, change. So really, this is saying 7/8 plus negative 1/6. Okay, once you do the keep, change, we're back to addition. We got 8 common denominators. So 6 can't go into 8, and 8 can't go into 6. So what number can they both go into? And that's going to be 24. So I need to make 8 look like 24. And to make 8 look like 24, we need to multiply it by 3. To make 6 look like 24, we're going to multiply it by 4. So it's going to be 21 over 24 plus negative 4 over 24. And then 21 minus 4 is going to be 17. Yes, so 17 over 24, and that one can't be reduced, so that would be your answer. Okay, so one more. We're going to do the whole number again, so 5 minus 1/3. So remember, to make a whole number a fraction, we put it over 1, okay? And then we need to do the keep, change. Keep the first one, change subtraction to addition, and then change the sign of your last fraction. So if that last fraction was negative, we would have changed it to positive. So we really have 5 over 1 plus negative 1/3. Now we got to get them to look alike. So 3 can't go into 1, but 1 can go into 3. So we multiply this side by 3. We don't have to do anything to the right hand side, so we're going to have 15 over 3 plus negative 1 over 3. So 15 minus 1 is going to be a 14 over 3 as your answer. Okay, so we're going to do the same thing except with rational expressions. Okay, so first you're going to factor the denominator completely. Don't worry about the numerator yet because you're going to be combining like terms. So factor that denominator completely because you need to know what's missing and what you need to add or multiply. Then you're going to do your keep, change like we did up there. Then get common denominator. Combine like terms, cancel any like terms. This is where you're going to factor everything right here. Okay, so you're going to factor again, except you're going to factor everything. And then you're going to cancel out your like terms and write in simplified form. Okay? All right, so number 1, we're going to start with a GCF 1. 3 over 8x cubed y cubed minus 1 over 4xy. So we're going to do the keep, change. And we have 3 over 8x cubed y cubed plus negative 1 over 4xy. Now we're going to multiply by what we're missing. Okay, so this has an 8, this has a 4. Well, 8 can't go into 4 because you can make 4 look like 8. So we're going to multiply this by 2 to make 4 look like 8. Now look at your x's. This is an x cubed, this is an x. Well, this has 3 x's, this only has 1, so we need to put 2 more x's over here. This has 3 y's, this only has 1 y, so we need to put 2 more y's over here. When we do that, so this left-hand side is fine, so we're going to leave that left-hand side alone. Okay. And then we're going to have plus, now we're going to multiply, and it's just going to be negative 2x squared times y squared over your new common denominator. Okay, now we can smush. There's really nothing to smush up top. There's nothing to combine. So it's just going to be 3 minus 2x squared y squared over 8x cubed y cubed. And the 3 and the 2 and the 8 have nothing in common. So that's your answer. All right, number 2. Number 2 is going to be, let's see, x plus 12 over 4x minus 16 minus x plus 4 over 2x minus 8. Let me write that x. Whoops. X plus 4. There we go. Now, the last one we did, and then the rational fractions up there, we only had one term up top, so we just made that number negative. But here you have 2 terms on top, and you're actually going to have to distribute that negative to everybody. So this question, when we do the keep, change, oh my goodness, I don't know what's going on. Okay, you're going to keep this first fraction. I have no idea what's going on right now. Over its denominator. Yeah, that's wonderful. Change subtraction to addition. And then we're going to distribute that negative. So it's going to be negative x minus 4. Negative x minus 4 over, you get the denominator same, 2x minus 8. Alright, so now you factor the denominator. So this is going to be a GCF because this has a 4 and that has a 4 in common. So when I GCF factor it, it's going to be x plus 12 over 4x minus 4. Okay. Then plus negative x minus 4 over, we can pull a 2 out here, so it's going to be 2 times x minus 4. So see, when you factor it, it actually revealed that it had an x minus 4 in common. So they looked really completely different, but they're actually kind of very similar. And then when you looked at the constants, or the coefficients, it's a 2 and a 4. Well, I can times 2 by 2 and get that 4, and that's all you have to do. So I'm going to distribute that 2, and I'm going to have x plus 12. 2 times negative x is negative 2x. And then 2 times negative 4 is negative 8. And then it's all over the common denominator, where the common denominator was definitely x minus 4. And I made that 2 look like a 4, so that's the common. Combine like terms. I got an x and a negative 2x, which is going to be negative x. And then I have a 12 minus 8, which is going to be plus 4, all over 4 times x minus 4. And there's nothing I can cancel out. It's already factored for me, so that's my answer. Okay? All right. So that was number 2. Let's go on to number 3. Number 3. Okay, my number 3 is going to be x over 2x plus 4 minus 3 over x plus 2. Alright, so first things first, keep, change. So when I keep, change, I'm going to have x over 2x plus 4 plus negative 3. I didn't have to distribute but to one number there over that. Okay? Now, factor the denominator. But the only denominator that can be factored is the left-hand side, and I can pull a 2 out. So I'm going to have x over, pull the 2 out, and it's going to be x plus 2 plus negative 3 over x plus 2. And see, when you factored it, you see they have an x plus 2 in common, right? But but this guy over there is missing that 2, so I'm going to multiply him by 2. I'm going to multiply him by 2. I didn't do anything to the first one. And then 2 times negative 3 is going to be negative 6 over 2 times x plus 2. Okay? Can't reduce that anymore, and that's your answer. All right. Number 4. Number 4. So 2x over x squared minus x minus 2 minus 4x over x squared minus 3x plus 2. Alright, so I'm going to do the keep, change. Okay? And guys, if you can combine steps, go ahead and combine them. You can do the keep, change, and factor the denominator at the same time. But I'm going to do it this way so I can make sure you guys see every step. Change subtraction to addition, and then change the sign of the 4x, which will make it a negative 4x, over that denominator. Now we're going to factor the denominator. You can go to Desmos and factor them. I've already showed y'all how to do that in multiple videos. So we've got 2x over, this is going to be x minus 2 and x plus 1, plus negative 4x over, this one's going to be x minus 2. Oh, that's supposed to be a plus. That's why I was like, hold on, x minus 2 and x minus 1. Okay, so that's actually a plus. I didn't copy it down right from over there. Okay, so what do they have in common? They have an x minus 2 in common. Okay, these are not alike, not in any way. Okay, they don't share nothing. It is a whole nother factor. So I need to multiply this side by x minus 1, and I need to multiply this side by x plus 1. Okay, they have nothing in common. Okay, so this is now going to be distribute the 2x. You're going to get 2x squared minus 2x. Distribute the negative 4x, and you're going to get negative 4x squared minus 4x. All over, what's your common denominator? It's all 3 of those. X minus 2, x plus 1, x minus 1. Okay? Clean up the numerator. 2x, negative 4x is going to give you negative 2x squared. And then you have your negative 2x and negative 4x. That's going to be a negative 6x all over. Now you can factor that numerator by pulling out, remember I told you it's a negative, go ahead and pull the negative out. We're going to pull out a negative 2x. And it's going to be x plus 3, which does nothing for us. Okay, it's an eraser. I forgot I changed the size of my eraser. Don't like that. Alright, so it really doesn't help us much, but either answer is correct. I ran out of room. Okay, either one. I factored it just to see if I could cancel anything out, but I can't. Okay. All right, number 5. Is going to be 2x going to be 2x, whatever, 2x over 3 minus 9x over 2. So, this one I wanted to give a, because you'll see these in your Delta Math you're going to do later this week. Like 3 can't go into 2 and 2 can't go into 3, but they both can go into 6. So 3 times 2 is 6 and 2 times 3 is 6. So now I have, oh, I forgot to do the keep, change. Sorry, so you can do it in any order. Keep, change. Okay. So I'm going to have 2x over 3 plus negative 9x over 2. So again, we can make it look like 6. So I'm going to multiply this by 3, multiply this by 2. And now I have 4x over 6 plus, that's going to be negative, 27. Yeah, negative 27 x over 6. Well, 4 minus 27 is going to be negative 23x over 6. And you can't simplify it because 23 is prime. Okay? All right. So now we're going to do number 6. All right. This one's going to be 6 over 7x minus 1 over 5x. So keep, change. 6 over 7x plus negative 1 over 5x. Now, this is where it is okay to say they have an x in common. Okay? They do have an x in common. They're not in that factor form. Okay? They have an x in common, but the 7 and 5 can't go into each other, but they both go into 35 together. So I'm going to multiply this by 7, multiply this by 5. So that's going to be 30 minus 7 over 35x. Well, 30 minus 7 is 23 over 35x, and you can't simplify that. Okay. All right. Number 7. Right? Yeah. Number 7 is going to be 3x over x plus 3 minus 1. Here we got the whole number. If you have a whole number, go ahead and put it over 1, and then do your keep, change. So it'll be 3x over x plus 3 plus negative 1 over 1. Well, obviously we're going to multiply this side by x plus 3. And we've got 3x, distribute the negative 1, minus x minus 3 over x plus 3. 3x minus x is 2x. I can't factor the numerator, so that is it for your answer. Okay? All right. So now this is number 8. Number 8 is going to be, ooh, let's do one of those special ones. Remember that last problem I did on the adding video? Let's see when you're watching this if you're like, oh, I remember that. Now, there's multiple ways to do this one. So if you're watching this video and you're not one of my students, I usually try to keep what I do the same. So yes, there is another way to do this one, especially with it being subtraction, but I'm going to keep it correlated with the addition one. So if you know the other way, go ahead and do that one, okay? So keep, change. 7, and I'm going to write this in standard form, negative x plus 7 plus negative 7x minus 1 over x minus 7. So remember I told you last time when they look very similar, they're just opposites of each other, like negative x, positive 7, negative x. If they're just opposites of each other, we're going to move negative up top. So factor that negative out. Okay, and so when we do that, we'll have negative 7 over x minus 7 plus negative 7x minus 1 over x minus 7. So they have the same denominator now. So now we can combine like terms. Negative 7x don't have a like term, but negative 7 minus 1 is going to be negative 8 over x minus 7. And that's your answer. Okay? All right. Number 9. Number 9 is going to be 5x plus 3 over x minus 2 over x minus 3. Keep, change. Now, these two have nothing in common. These are two different factors. X is a whole different factor than x minus 3. So that means I need to multiply this side by x, and I need to multiply this side by x minus 3. Now this you're going to have to do the box. So now I'm going to have 5x squared minus 12x minus 9. The next one I'm just going to say negative 2 times x versus negative 2x. All over your common denominator is x times x minus 3. Clean up the numerator. Been making too many videos, my computer's going crazy. So 5x squared doesn't have a partner, so we just bring him down. But negative 12x and negative 2x make negative 14x minus 9 over x minus 3. Now, I would check to make sure that it's not factorable. And since a isn't 1, a quick look will just be your graph. Okay? So we're going to go to the graph. We're going to go to Desmos. And we're going to have 5x squared minus 14x minus 9. Quick look. They're not pretty. It's not factorable. So there you go. That's your answer. Okay? All right, number 10. Let's go to the next page. Number 10. Let's do another one like that. 3x plus 7 over x minus 3. So, keep, change, change. Now, when you keep, change this one, you have to change the entire numerator, not just that first term. So, this is going to be 3x plus 7 over x plus negative x plus 3 over x plus 7. Okay? Now, again, these are two different factors. I need to multiply the left-hand side by x plus 7, multiply the right-hand side by x. Okay? Now, the first one, you need to do the box method. Okay? And so the first one's going to be 3x squared plus 28x plus 49. Okay? And then you just distribute the x here, so it's going to be negative x squared plus 3x all over x times x plus 7. Okay? Combined, I can combine the 3x squared and the negative x squared and get 2x squared. Then I can combine the linear terms. Lord have mercy. 28x and 3x, and that's going to be 31x. So plus 31x, and then the 49's by itself. Now, I don't think it's factorable, but I've known things to look not factorable and they're factorable. So it wouldn't hurt to do a quick Desmos check. Okay? We're going to Desmos. We're going to do, go away keyboard, 3, okay, 3x squared, that's 2x squared, right? Yeah. Plus 31x plus 49. Yeah. And they're not, it's not factorable. Okay, so that is your answer. Okay? All right. And that's it. Okay? If you need some more examples, let me know. I can add on. I'm going to do a review, probably one, when we do all of them on Friday. Okay? So, good luck, and let me know if you need more help. All right, guys. Bye.